Hey everyone, it's that math magician, and on this video we're going to take a look at the law of sines. And the purpose for this video is to introduce what the law of sines is, and more importantly, when we should use it. So let's jump right into this video and discover what the law of sines is. Now we have a lot of tools that we can use to solve for unknown sides or unknown angles in right triangles. Right? At this point, we've come up with sine, cosine, and tangent. Remember our trig ratios. We also have Pythagorean theorem. That also lets us find a missing side. And then we discovered that there are some special right triangles. We have our 30, 60, 90 triangle. We have our 45, 45, 90 triangle. And then we even learned that there is what we call Pythagorean triples, right? So we have 7 different ways that we can solve for unknown sides of right triangles. And it's great that we have those. They work really well. If you know how to use them, then they're not too complicated to use. But what I'd like for you to understand is that not all triangles are right triangles. Actually, only a small set of triangles are actually going to have a right angle. So the point of this video is, what do you do when you're trying to solve for an unknown side or an unknown angle of a triangle and it doesn't have a right angle? Sort of like this triangle here. You notice that that triangle there has no right angle, and so we can't use any of the trig tools that we know to solve for unknown sides or unknown angles. Sine, cosine, and tangent, they all fail because it's not a right triangle. The Pythagorean theorem doesn't work here because we don't have a right triangle. The special right triangles that we learned definitely won't work because this is not a right triangle. And Pythagorean triples are not going to help us. So the point of this video is to introduce to you another tool that we can use to help us solve for any side or any angle for any triangle. And that is the law of sines. Now before I write down what the law of sines is, we first need to label this triangle with some letters so we understand what angles we're talking about. And it might be a good refresher for you too, just to remember, how do we label a triangle? So I'm going to go ahead and call this triangle ABC. And you'll notice that I'm using capital letters there to refer to those 3 different angles. When we're labeling a triangle, capital letters will always be used when we're talking about an angle. So I know that that angle there is the capital B. I know that this angle over there is the capital C. And then we have this angle here for A. So those are the 3 angles, A, B, and C. Now I also want to label the sides for this triangle. And what might not be as well known to you as I hope it would be, is that when we're labeling the sides of our triangle, what we're actually going to do is, we see I have angle A over here. We notice that as I move across from angle A to this opposite side here, that I'm going to label this side with a lowercase a. So normally when we have a variable for triangles, the lowercase letter represents the side, and the uppercase letter represents the angle. Okay, and the angle here and the side, they both have the letter A, and they're sort of corresponding to each other in a sense that this side A is just opposite of that angle A. I'm going to do that same thing to label this side. We see that there's my angle B. It has a capital B. I go across to the opposite side, so I'm going to call this long side here B, but a lowercase b. And then finally, up here at the top, we see this capital C is there, that angle C. Across from it, I'm going to call this side a lowercase c. So I just wanted to make that point to you. You might have picked up on it on your own. You might not have. It just depends on what your teacher tells you. But really, the main point of that is that when we're using capital letters such as A, B, and C, those all refer to angles. Okay, when we refer to the lowercase a, the lowercase b, and the lowercase c, those all refer to sides. And the sides are just opposite of those angles. All right, just a little note keeping that I wanted to make sure we focused. Now, we want to introduce law of sines because like I said, there's no right angles in here, so sine, cosine, tangent, none of the trig stuff we normally use is going to help us. So let me write down what law of sines is. And it's kind of a messy equation, but I want you to understand that it does not require too much work to use, but when first glance, it is going to look a little confusing for you. So the law of sines is actually a bunch of fractions that are equal to one another that also use the sine ratio. We call it the law of sines because it uses the sine ratio. And what that is going to end up looking like is we're going to talk about how sine of A, so sine of this angle A, we're going to put that over the side opposite of A, or the lowercase a. And that's our first fraction. And as we move to the other set of fractions there, the law of sines is going to keep saying that I'm going to take that angle, angle B, and I'm going to put it over the side of lowercase b. Same thing over here with this last one, sine of uppercase C over our little c. Now you might be scratching your head thinking, why do we have an equation here that has two equal signs? And that's because all of these ratios equal each other. Now when you're actually trying to solve for an unknown side using the law of sines, you actually would really rarely ever write it out with all three fractions. You're only going to be interested in two of those ratios where you're able to solve for an unknown side or an unknown angle. So what I'd like to do now is that we have this introduced, and we know that law of sines is going to be used when we have a non-right triangle. I'd like to do a quick example of how we can actually use that to solve for an unknown side. So let's say that I knew that B here actually had a side length of 21. Let's say that I knew what the angle of B is. Let's say I knew that the angle of B here represented, let's see, it's obtuse, it's greater than 90 degrees. So I'll say that it equaled 110 degrees. And then let's say that I knew what this angle A also equaled. Let's say I knew that angle A here equaled, let's do 31 degrees, right? Just making up some numbers off the top of my head. But what we want to find out is what does A equal? What does that missing side equal? And before we wrote out this law of sines, there's really no way to solve for it. We can't use our normal trig tools that we have because this is not a right triangle. But now because of law of sines and these ratios that all equal each other, I can actually set up an equation to help me solve this problem. Let me show you how. I know that sine of A is going to be over the little side of A. Well, I now know that A here equals 31 degrees, so I'm going to erase that A there and instead write sine of 31 degrees over the side A, which is what I want to find, so I'll leave that as A, equal to sine of B. Instead of writing the letter B, I'm going to write what the angle is, 110 degrees, over the side across from that angle, the little b, which is 21. So if you're looking here, you're noticing that all I've done is replace those letters with the numbers that represent those angles and sides. And I have no information about the C angles or the C sides, so I'm really just sort of going to ignore that because it's not really pertinent for this problem. And you see there that I have two fractions equal to each other. I have one variable. This is something that I can definitely solve for to determine what that missing side of A is. All I need to do here is with those two fractions is to cross multiply those fractions and solve for A. So let's go ahead and do that right now. I'm going to cross multiply this, so I see that I'm going to have A times sine of 110 degrees. That will become A times sine of 110 degrees equals, let's cross multiply the other side, 21 times sine of 31 degrees. That will become 21 times sine of 31 degrees. Now I know that some teachers might have you put this into your calculator to determine what that number is. I'm actually going to hold off and wait for that before I get to the final step, because I want to put it all into the calculator at one step. I don't want any rounding business happening until I get that final answer. Okay, so I have a over here by itself. Actually, not by itself. It's with sine of 110 degrees. So I need to get rid of this sine of 110 degrees. To do that, I will just divide both sides by sine of 110 degrees. When I do that, those signs there are going to cancel. And what I'm left with now on that left side is a, all by itself. And it equals 21 times sine of 31 degrees, all divided by sine of 110 degrees. We now know what a equals. I want you to take a moment to just appreciate that. We're able to solve for a on a non-right triangle. We now can find the length of this side using the law of sines, and just by cross multiplying and solving and getting our variable by itself. Now just a quick note, I know some students might look and see, oh, I see that there are signs there. Maybe I can just cancel out those signs. That's not how that works. The math police will come and grab you up if you try to do that move. You cannot cancel those signs because this is sine of 31 degrees and sine of 110 degrees. Two separate things. We cannot cancel those out. So the last thing you have to do now is just enter this into your calculator to get your approximate answer for a. I'm going to go ahead and open up my online calculator at desmos.com to use that to enter this whole expression in to figure out what a is. So I have that calculator here, and now I can enter in that expression to figure out what a equals. So I'm going to go ahead and first click on this fraction button so I can create my fraction. And when I press that button, we now have, whoops, I made too many fractions. On the top as my numerator, I'm going to type in 21 times sine of 31 degrees all over sine of 110 degrees. I type that in, and I see that that missing side for a is 11.5099. I probably would round that to 0.510. So that is what a ends up equaling, 11.510 approximately. But that's how we use the law of sines. We can now solve for any side on any triangle just by using the law of sines. If, it's a big if we know some of the angles inside and some of the sides on that triangle as well. It's that math magician, and I'll see you on the next video.